All right. Looks like we are live, folks. Awesome. Welcome to the live stream. We'll do a quick round of intros here in a second. But a couple just housekeeping notes before we get started. If you have questions or comments during any of the live stream here, just go ahead and put them in the comments and we'll get to them in real time. And let's see. I'm in from Austin. I know, Eric, you're in Austin. Márton, where are you dialing in from, man?
Well, I'm from beautiful sunny Budapest. It's a really nice afternoon over here in Hungary.
Nice. Eric, I can vouch for your weather. I'm looking out the window and I think I can see your house. So
yeah, weather same over here. Yeah, it's pretty nice out there.
Hopefully it's not different. Awesome. Well, welcome everybody. So, a couple things here. Normally Dinesh runs these and he's way better at moderating than I am. So I'm filling in. You're going to have to deal with me. But we'll see how it goes here. And we are super pumped to talk about Flink Forward. We occasionally do these after conferences. We're going to talk a little bit about our thoughts and what we saw at the conference. And then we're going to do a quick demo for you too on the community edition. So that's pretty exciting. Let's just do a real quick round of intros. I already said your name, Márton. Why don't you just give a brief intro so folks who don't already know us will have a little bit of context and we can kind of get started that way.
Sure. I lead the Flink engineering team here at Cloudera. Started with this team around 2.5 years ago. And my background in Flink is that I was one of the folks who had the pleasure of initially working on the streaming API around 7-8 years ago. And that earned me a seat at the PMC. That's basically about me.
Eric, what about you, man?
Hi, I'm Eric. I've been using Flink for a few years now. Have had the pleasure of working on SQL Stream Builder for a couple of years now. Spend most of my time working on the things that Kenny's going to demo for you in a bit.
Yeah, awesome. Yeah, so my name is Kenny Gorman. I'm the product owner for stream processing here at Cloudera. And I work with both Eric and Márton on bringing products to you guys, the customers. It was funny. Eric joined this morning, and the first thing he says is, "Good morning, streaming enthusiasts." That's still ringing in my head. So if I happen to say that a few times today, it's Eric's fault. So anyway, let's jump into it. Márton, I'd love to hear kind of what your thoughts were coming out of the conference. You mentioned a couple of things when we were talking earlier. I'd love to kind of get your thoughts and share with folks what you saw and your takeaways.
Yeah. So I've been tuning into Flink Forward since the first Flink Forward in Berlin. I think that was maybe it was 2015 or 16, something about that time frame. And it was awesome to see how much the community and Flink in general has matured in that 5 years time period. So if you look at the program, this past conference, it was very much about adoption and use cases and people sharing their experience of running and optimizing Flink for 2-3 years in production. So that's awesome to see how much the community has matured in the past 5 years. And obviously that also shows in terms of the features and functionality that we have been seeing. Erik, what was your favorite feature that showed up in the talks?
That's a good question. Like you mentioned, kind of the history of Flink Forward. We've been going for a few years now, it's great to be able to watch these, sitting at home now, streamed on the internet. But every time I watch these, I do think back, when you actually go there, the awesome energy around, the people and. Even the vendors and stuff that all set up there talking about the things that they built. It's always one of the coolest parts of the conference for me. So I love watching them online, but every time I do, it makes me think I can't wait until we're actually able to travel to these again and hang out with everybody. But your question about what was kind of my favorite. It used to, it seemed like in the years past, there was a lot of talks around specific features and how it was evolving. I thought one thing this year that was pretty interesting was there's definitely a lot more focus on CDC, which I think is great because we've kind of talked for a while that like people kind of mentally partitioned that like streaming was you had to you ultimately had to rewrite your applications or modify your applications or start thinking about microservices differently or whatever to take advantage of streaming, when in reality people have had relational databases that wrote streams in the form of a wall log or redo log or whatever to disk for 30 years now. And seeing more people take advantage of the fact that like they're already ultimately writing streams in their in their traditional applications, and it's really just a matter of like mechanics of thinking about thinking about how those updates happen, capturing them, enriching them, doing something with it, and ultimately like you can if you have any traditional application stack, you can be streaming in almost in almost no time and start taking advantage of that. So I there was one interesting talk. I was looking through their slides earlier. It was Gunnar Morling and Hans-Peter Grahl. I'm probably saying his last name incorrectly, but the slide, they released their slide deck, and I saw it on Twitter this morning, and I was looking through that, and they talked a lot specifically around Debezium and streaming patterns, interacting with the databases that I thought was great, and it's nice to see more of that.
Mm-hmm.
Yeah, go ahead, Martin. I was just going to chime in.
Yeah, sure. Just to tie back into that, so Erik, you talked about semantics, and that certainly helps show maturity, that now we are talking to relational databases directly, and we leave that to a certain extent, but I wouldn't say we leave out the rest of the big data stack, but it's not a mandatory portion that, first you need to drop things to Kafka or some other intermediary. Flink can just talk to the system. But also on the other side, just double tap on the operation/scale. We also had a talk by Yaroslav from Shopify, where he also talked about CDC, but he said, well, let's just grab the whole history of all user item interactions at Shopify via CDC, as you mentioned, literally tens of billions of messages. And instead of doing lookups to a database, which the database wouldn't be able to handle, let's build that state up in Flink. And that takes 150 instances of task managers, like over 600 of parallelism, and let's just build it out. And in 3 days of grinding through backlog, they did that, and now they have the fastest lookup they could ever imagine in a Flink job. And
I love it. Just dump everything into Flink, whatever. Screw it. It's amazing.
And going back when the community designed the fault tolerance algorithm and the stateful processing in Flink, maybe we had the ambitions to be able to tap into use cases like this, but that seemed far-fetched at the time. And it's awesome to see this unfold and being able to listen to these use cases. One other talk that I really enjoyed that touches roughly on this scale and operations story was by Andrei Falco from Salesforce, and he specifically talked about his mental model of maximizing uptime for Flink jobs. That's an awesome talk as well that I would highly recommend to check out.
Yeah, I know, it's interesting. I think it was I was listening to the keynote, second day keynote, and it was like that panel, and I think it was Eric Samwer that was talking about, like, he was saying something, I'm paraphrasing, but he was saying something like, sorry, but not everybody is streaming first. We don't always get to go to first principle to design systems, and that totally rung a bell with me. I think from my past experiences, but also at Cloudera, we run into that a lot. And he was talking about CDC and where that fits in there, and hey, you may already have data in a database, but it doesn't mean you can't stream. And yes, it would be nice if we could always design our company from scratch or redesign it from scratch, but that's not always a reality. And so how does, given that, it's easy to kind of design an architecture from scratch and say this is how it should look, but given the realities of a real production system and the history of a company, how do you then weave it into your architecture and make best effect of it? And I thought that was a really deep point. I mean, if I was there, the moderator for that, I would have been like, let's talk about that more, because I thought that was interesting. And, you know, I, I think you mentioned an interesting point. I'm losing my voice. It's not that I'm getting choked up. I'm just losing my voice. Márton, when you said CDC directly from Flink, I think that is one of the things that's really undervalued, because the state of the art right now is that people will do CDC, right? And you'll just drain it. You'll drain every possible change vector from a redo log or whatever into Kafka. And then you've got this massive Kafka stream, event stream, and you've, you know, lots of data, lots of moving parts, scalability becomes an issue, you know, lots of work and moving pieces. Where in Flink, you can just selectively attach and grab what's of interest. And you do that via a declarative query language called SQL. Like that is, to me, and we're starting to see customers kind of have those aha moments. To me, that is where Debezium and Flink and the integration there is just super exciting. So you guys kind of inspired me on kind of both fronts there in your comments.
Yeah, CDC is interesting via the Flink Debezium wrapper, where we just use Debezium as a library for the same reason for me as well, because of course we can just see the semantics that it opens up, but more pragmatically, if you put this into an enterprise context, you cannot simply say that, oh, I'll just grab the replication log, because if you want to be a good citizen on Kafka, as you said, Kenny, you have to obey certain consumer producer quotas in most enterprise systems, obviously, and then you will need, at some point, you will run into those quota limits and you will need to provision more of those. Of course, in an ideal world where you control all of the infrastructure and you happen to have infinite of those, that's not a problem, but I'm yet to see an enterprise like that.
Yeah. Yeah. And, you know, I think one thing I would have liked to see more of, and maybe there were some sessions I missed, but, you know, schema management is still a thing. You know, managing schemas, data serialization protocols, and how, you know, we see that in the real world a lot. I think that's something that, you know, maybe next time it inspired me to maybe we should talk more about that, because I didn't see maybe enough talk about, and that, you know, that's also a Kafka kind of talk and to some degree, right? Like for the most part, folks are serializing data in Kafka in some format, and that's, you know, we just use it in Flink as a, you know, as a source or whatever. But I don't know, that was one of the areas I thought, you know, it'd be interesting to kind of maybe add some more content next time, because I think that's an area of this whole, you know, architecture and ecosphere that's still kind of a mess, and still an area I think that as a community we can, you know, make impact and make things better, I think.
Yeah, it's interesting now that you say that, because there were actually multiple talks around Iceberg. So two talks that I would recommend. One was by Thomas Wise from Apple, but Thomas is a long-time Flink contributor. He started his work way before he joined Apple. And also there was a great talk by folks from Netflix. In both cases, they examined how you can, in the Netflix case, they call this to be able to backfill data. So let's say you have been running on a Kafka topic, and then you recognize that, oh, I actually had data that was erroneous in the middle. Let's backfill that portion of the data, or let's restart with a new version of the job, things like that. Thomas specifically worked on the hybrid source interface in Flink that lets you do this type of work. And the important part there is Iceberg as a table format inherently has and enforces to a certain extent a schema on you, but Kafka doesn't. As we know, that's just byte arrays in Kafka. So you have to bridge that gap, and that both talks lightly touched on this topic, but I agree that maybe I just haven't been to sessions where this was front and center, but that's certainly something that the community needs to discuss a bit more, because at least in my experience, the integration with the Kafka schema registries, although exists, both for, let's say, the Confluent and the Cloudera implementation, it's still a bit light, and it needs to be more prominent.
Yeah, it's funny that, you know, when we started off, we were talking about kind of how far things have become with the whole ecosystem, and it makes me think back. Like, I think that panel was also talking about is streaming the system of record now? When is the streaming data the system of record? When's the day that we declare that, like, that's a normal and reasonable thing to do? And I think, like Confluence probably already called that, said that that day's passed. I don't know if Oracle wants to say anything about that, but it's interesting to me that as a community, we've gone from, kind of like, okay, a streaming use case bolted on to the enterprise, and that's cool, to no, my enterprise is made up of streaming use cases, and we're the glue that connects systems of record and traditional databases and applications and, the whole thing. And I think, microservices are a big part of that. And how do we, empower these services with data? That's an interesting topic. And I think, there's a number of talks that kind of touched on that topic, but man, it could be a whole talk in itself about how that lineage has kind of grown over time and things have expanded, and ultimately now streaming systems are, if you drew a pie chart, they would be a much bigger piece of the enterprise, at least from a philosophical standpoint, than it was before. I don't know if you guys kind of saw that trend as well.
Yeah, we certainly did. Of course, it's maybe a bit more difficult to quantify those. In the olden days, the way they quantified at least, let's say, batch Spark jobs was that, oh, we run this many jobs, we run 5,000 Spark jobs every week, or something similar with this many executors. Well, streaming jobs are a different beast. You just run them forever. And they also have a tendency to maybe unify more sources, and maybe you have a lower number of jobs than you had for the batch ones, but they run 24/7, and you can become quickly dependent on them. So you need to have a story that is operationally sound.
Yeah, I think that's the interesting kind of paradigm of transitioning from, writing, streaming jobs, kind of solely like in like traditional strongly typed languages, Java, Scala, that kind of thing, to streaming SQL, is, you start to have, the ability to, to more easily experiment with them, to kind of, turn those into reusable components around the organization. Whereas, like, prior to this, it was, a lot of times, even, you talked about schemas, Kenny. A lot of times, there was no, explicit, relationship with like some schema registry or something. It was just like there was some contract with the, between the data and the software that you're writing on top of it. And, the only way you would iterate on those streaming jobs was through like your normal software development lifecycle. And, whereas, moving towards streaming SQL, you end up with, you start to visualize these streams as virtual tables, and the virtual tables have an inherent schema associated with it, and maybe you interact with them using user-defined functions that themselves are kind of standalone programs that you can introspect, you can debug, you can iterate on. So you start to have more visibility and more reusable components around the organization. So you get more value out of the streams that you build, because more people are able to to reuse those without having to start a ground up new streaming project.
Yeah, for sure. And at scale, right? Like this Flink Forward, I think people use the word billions way more than the last one, right? It was over streaming billions of events per hour now. And that was kind of normal. I think before, if someone said we're streaming 1 billion events per whatever day or something, people would be like, wow, that's a lot. That 4 years ago. I think now, like you mentioned, Márton, just stream all the things, just put them into the streaming context so we can then analyze them. It's, it's relatively easy to scale and manage. So, let's keep that data fresh and make the most value out of it. Inside Flink, I think, Shopify's, that's, if they're putting their entire database history into Flink, then they're obviously bought in on that. They want instant and very low latency access to a lot of particular pieces of information. And I didn't see that talk. I'm gonna go check it out now. Probably to drive user functionality and user satisfaction and make a more compelling and wonderful experience for their users. Like, that is the promise of stream processing, right? We've always kind of, as we talk about that all the time. So that's super cool to hear about that use case.
Also probably why it's so important to be able to kind of sift the data in a meaningful way. You use billions, and that used to be a big number, but now
Right.
You know, in the stream everything paradigm, you know, a small or medium business, you know, will stream, you know, billions of events, you know, a day, just, you know, as a result of like, you know, application logs or you know, click logs or you know, transactions from, you know, if you're doing CDC, then now all your database, you know, all your database updates are you know, are events too. So that number becomes big pretty quickly.
Yeah.
Yeah. Once you have tens of millions or hundreds of millions active daily users, a billion is not that much anymore.
Right. Right. Like actions times users gets big quick. Right. Yeah, totally. What do you guys say? You want to do a little demo of anything else about Flink Forward, and maybe it's a demo time? What do you guys think?
I would love a little demo.
All right, so you're gonna let me demo. This is sketchy. All right, cool. So stop me if I'm doing anything wrong. So let me let's do this. Let me just kind of orient the users and tell folks who are on the live stream kind of what's going on here. So so I'm just pulling up a blog post here. Hopefully you can see my screen. So as part of Flink Forward, we announced the community edition of Cloudera Streaming Analytics, or CSA. So you'll hear us call it CSA acronym. And we introduced that as a Docker compose, so you can run it in Docker. And I'm just going to go through it now and show it to you, just to give you a feeling for why we did this. Just a little background. One of the things I think, you know, everybody on this live stream, we're very passionate about the community. And Erik and I have been working on SQL Stream Builder for a very long time. Márton's been working on Flink for a very long time. And so we have this kind of, you know, great team aspect of, you know, group here and the community here, and the engineering team is amazing. And we all felt very passionately that we wanted to be able to get the people get their hands on this software as soon as possible, play with it, give us feedback, build and use it as your development tool, and you know, build streaming SQL jobs with it, and you know, and kind of go that route. So this was kind of our mental model. We wanted to provide it and make it easy and super quick for folks to get started. So I'm going to kind of drive through that here real quick and kind of show you that. So I'm starting at this blog post. It was kind of the announcement. It talks a little bit about what's going on. The bottom line is you can scroll down to downloading the Docker Compose file. So there's a link here in that blog post to do it, to download it. And I think these links will be presented as part of this as well, as part of the live stream. So you should see those. There's a getting started guide, which helps you with the first couple queries and getting it up and running. And then we have like our general documentation. So I've actually already, let me just show you here. I've got a terminal. So I've already got that Docker Compose file pulled down. So I'm going to start from that perspective. So I'm in just in my home directory. I'm in you know, another directory called SSB2. And let's just do Docker Compose up here. This is in the docs. Let me pull up the docs here so I can show you. So if you go to installing community, and this is all linked as well, by the way. So you can see here, I'm just copying and pasting the stuff from the docs. Okay, so Docker Compose up. I'm not going to run it with the D because I want you to see all the logs. And obviously I've got these Docker images locally, so it's not gonna take as long as it would if you don't have any of these images. I'd have to pull them down to your box. Now you can run this on your laptop, on a cloud node, whatever it makes sense, where you're running Docker. And the license, just to kind of put a fine point on it, this is not 100% of the functionality. It's a lot of it. Just there's some things like change data capture. We talked about that earlier today. Hive and Kudu catalog connectivity, and a few things that aren't in that because it's not part of the standalone platform. So to give you a feeling for like, you know, what that looks like. And it's a fully featured or fully, you know, all the pieces are here. So we have, you know, Zookeeper and Flink and Kafka and SQL Stream Builder and all of it. So, all right, so it looks like that's coming up now. I can just go to localhost 8000. And it's going to log me in. Normally it'll ask for your password but I've already been logged in, so it's got that cookie. All right, so this is SQL Stream Builder. It's running on my box. It's kind of that simple. You are up and running with, so I'll show you here in templates, and I'm sorry for my screen's not as big as it would be, but I've zoomed it in so that you guys can see it and read it. But here you'll see that we don't have some templates for CDC and some things aren't supported. You'll notice if you poke around that the catalogs for Kudu and Hive aren't there. But really, that's about the only thing that's not part of this version. So this is CSI or CSA 1.5, and the very latest version of SQL Stream Builder that's in production. So let's run a couple queries. I'm going to go over to the docs here and just copy paste from here. I'm going to go to the quick start guide, and let's just create a table. Okay, so this is typical Flink DDL stuff, and I'm just going to copy paste this into the editor. I'm assuming this is what you guys would do as well. And let's just kind of talk through it. So first of all, it drops the table if it exists. In my case, it does. I already tested this. And by the way, if you start and stop this, the Docker state is saved. So if you create a table or views or whatever, and you stop Docker and then restart it, all that work is persistent in the Docker volumes. All right. In this case, I'm just going to create a faker one. So this is going to create fake orders. So let's go ahead and execute that. And if you're not familiar with SQL Stream Builder, it might be like, what just happened? So what's happening in the background here is we're actually creating Flink jobs, essentially. So, it wasn't using Maven or compiling Java or copying jars around. I literally just typed in Flink SQL and hit run. And it knows the context of SQL Stream Builder. It knows how to run jobs. It knows how to give me feedback. It knows all those things. And it also, and this is new in 1.5, successfully traverses the divide or the impedance mismatch between bounded and unbounded. So you'll notice that a DDL expression like create table is bounded. It finishes, it completes, and the software does that successfully. If I were to run select star from some stream, it's boundless. It would continue to run as a Flink job in the background. So you don't have to worry about any of that. It handles the transition between batch and streaming quite nicely. So if you're querying a Kudu table, or in this case, maybe a JDBC table, it understands that that's bounded. If you join the two, like a Kafka stream and like a JDBC connection, it understands that as well. So fantastic functionality from that standpoint. All right, let's go back and run a query. You guys tell me if I should do something more interesting, but I'm just going to follow along here. So let's just show you like a regular, boundless query here. So I'm just going to copy that. Go here. So in this case, we're starting a Flink job, right? So it parses it for grammar. It makes sure that the schema is correct. It makes sure that you're doing everything correct. It will give you feedback if not, and then starts querying the faker data. So pretty simple, right? Makes sense. We can create materialized views from it. We can use UDFs, all this stuff. This is not a full demo right now, but it's all there and it's all included. So let's create a view real quick. And this is kind of our run through, our first our first how-to, if you will. So if you guys jump in here, run this stuff, give us feedback, and we're going to keep making more examples. So let's just, so we're going to drop a view. We're going to build that view. Again, that's just DDL, so it's going to finish. And then we can select from that. These are pretty simple queries. I'm just going to copy from here like that. So you don't need a semicolon. It's just habit, bad habits, die hard, I guess. And you'll see, notice it's starting a job here. And that job's running now. It's querying from the view. You can go into the job interface and pull up the Flink dashboard. And this is actually then the actual Flink dashboard as well. So all that's included. It's all on the desktop. I can develop and build jobs here with Flink SQL. As soon as I'm happy with the processing framework and whatever computation I'm doing, I can promote this to production and use this as my development environment. So that's a quick run through. Martin, Eric, do you have anything to add to my my make fun of me a little bit or add to my commentary there?
Yeah, just to add, in the demo that Kenny's doing there, you see the result data coming back. That's all getting piped through Kafka. You can see when he started his compose stack. It includes all the other componentry, so that Zookeeper
Right.
and Kafka. The docs have a couple examples of if you want to experiment with with SSB on top of Kafka. We provide some examples of how to put some data into that. into that Kafka. Kenny mentioned it's all persistent. It all gets written to a Docker volume. So if you create topics, you write data to it, it sticks around in Docker for you. There's a cool table wizard. So we talked earlier about
let's show templates. Yeah, should I show that real quick? Templates.
Yeah, that's or even good point on the template too. I was also thinking of under tables you can do you can do add table, and there's specifically a Kafka Wizard where you can detect a JSON schema. Where we'll it'll infer a valid schema for you to get started with. So it makes if you have existing data you want to play with, it makes it super easy to to kind of engage with it. It'll generate a working table for you right off the bat.
Right. So you can either use your internal Kafka, which is the one that's on the desktop here that we started up in a Docker container, or you could connect to like a cloud provider, your CDP cluster, whatever, wherever you've got data in Kafka, your own cluster, and register that, and then start querying that. So that's kind of how you'd start with that. And then you create a table here, right? So you go here, you'd say add table Kafka. You could name it. You could connect to the cluster, pick a topic. Right now we've just got this local Kafka, so there's not a lot of stuff in there. And then you can detect schema. So if it's JSON, you can detect schema. That's super helpful in a lot of cases.
Use one of the sample topics, you can even detect the schema on that.
Okay, let's do it.
Let's just try it. Let's experiment with something live, knowing that not the topic.
Oh yeah, the outputs. Yeah. Let's break it live. Is that what you?
Give it the name.
Yeah, you have to. Yeah, just pick anything and.
Yeah, that's okay. And now just detect schema.
Yeah, there we go.
We tempted fate and it paid off.
Yeah, and so this looks like the sample topic from the summaries table where we aggregated the order count by order status.
Right, and to point out, we have pretty robust control over event time, whether it's a column in the output that you want to use as your event time, or if you want to use Kafka timestamps. We mentioned schema earlier. You can also do input transforms. This comes up when you have like JSON data that has variable number of keys or missing keys. How do I get a correct schema from that? How do I look at that in SQL? Some cool capability there, especially with nested and complex structures. So that's kind of one of the things that we like to talk about a lot. And then so let's just since we're doing this live, let's just tempt fate even more. So let's say I wanted to say select star from orders, and I wanted a complete stream processing end-to-end job, right? I wanted to like where order, I don't know. Let's see here. Let's do this real quick. Desk orders, right? So we can describe it. And let's do amount, right? So let's say we say, this is our little processor. Select star from orders where amount less than 1,000. Okay, just some silly little filter there, okay? And now what we want to do is, so orders is our source, and we've got that defined as a faker right now, but it could be Kafka or something. And let's say now we want to insert that into an output topic, like that's our little processor. So I can go down to templates, and let's say it's going to be in Kafka. I could go down and pick Kafka, and I could say, let's put it into JSON. And what's super cool is it goes and it says, okay, I know the columns and data types for the output. So it's going to create an output table for me automatically. It's going to give it this, it's going to create a name for me. And then I can just give it a topic name, test me, and format JSON. And I can set all these other properties too, as you normally would. And then I can just say insert into, select star from blah, 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 order equals blah, 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 and run that. And that's my entire end-to-end processing framework. That's it. So super simple to build, relatively powerful stuff and do simple aggregations and filtering and all that stuff right within SQL and define the schema and all that stuff. So what I missed there, Martin? You can also do this, by the way. Something like that too. So if you wanted to route data dynamically, that kind of thing, it works the same way.
Do you want to touch on Kenny or Martin? Do you want to touch on like materialized views real quick too? Because that's another kind of neat thing that's included in the stack.
Sure. Yeah, let's talk about it real quick, and then we'll wrap. Let's finish on that note, if that makes sense. So materialized views what they're used for is connecting to external systems for the most part. So data science notebooks, Tableau, things like this, Grafana, stuff like that. So, and what we're going to do is we're going to make a view on the stream, and we're going to present that as either a REST endpoint or a Postgres compatible endpoint, wire protocol compatible endpoint. And the way you configure it is you just click on Materialized View for any query. You, first of all, have to enable it. It's going to go and it's going to read the keys. So actually, let me just clean this up here. Say, start from orders. Like that. We're going to enable it. It's going to read the key order ID. That's fine. We'll give it a retention seconds, maybe a few minutes, maybe an hour. If you really want everything in your history, like every log, every event that's ever happened, probably a JDBC sync is something better. If I'm feeding something like Tableau or something, I'm curating a view over time. So that's why this is designed that way. I add an API key. I'll just create one called KG. And then I can add a query. So I'll just call this orders. And I can select all the columns, say, in the output. I could add filters too, if I wanted to. So what I'm defining now is a pull query. And if you want to think of it that way, I save those changes. And now I have a REST endpoint that I can use, say, in Pandas in a data science notebook. So that's the quick run through of how that works and what you'd use it for. Anything else, you guys? And we'll wrap it up. Awesome. Awesome. All right. Well, Erik, Márton, thank you for joining us. Thanks for leading me through the demo, and awesome Flink Forward. I enjoyed it a lot. Every year it comes around, or now every year it comes around, and it's exciting. I agree with you, Erik. We got to get back to where we're going to Berlin, because that was the most fun one ever. So, and thank you, audience. Thanks for folks joining, and if you have follow-up questions, we're happy to follow up. Just ping us, and we'll get back to you.